Build Science 301, a Build Original series brought to you by Anderson Windows and Doors, Arkland, and Huber Engineered Woods.
Hey friends, Matt Reisinger here, and if you've followed me for any length of time, you know I'm big on performance, durability, and smart building solutions. Now when it comes to windows, Anderson has been the go-to for decades. Builders like me and homeowners who care about quality know the name and trust the product. Now in our Build Science 301 series, we're diving deep into one of the most impressive innovations I've seen from Anderson. It's called the Easy Connect joining system, and it's a total game changer when it comes to installing large window combinations. Instead of wrestling full frame heavy units into place, Anderson sends factory assembled sub-units ready to drop into your rough opening. They use interlocking fiberglass joining plates so you can connect units vertically, horizontally, or both with both precision and strength. Now, what does that mean in the field? Fewer crew members, no heavy lifting equipment, and way easier install handling. You get big window impact without the big window headaches. Even better, this system delivers incredible design flexibility without compromising structural performance. It's AMA 450 tested, Hallmark certified, and even HVAC approved when you pair it with Anderson's A-Series windows and reinforcing joining options. Air, water structure, this system performs at the highest level, while saving time, boosting install quality, and helping you build smarter, not harder. Want to see it in action? Go check out how Jake Bruton used it in one of his builds. You'll find the full video over at andersonwindows.com. Simplify your builds, strengthen your results. That's the kind of smart building science we love sharing here on The Build Show. I'm Matt Reisinger, and thanks for watching. I'll see you next time on Build Science 301. All right, my friends, welcome back to Build Science 301. You guys have hung with us for the last 10 episodes. We got our final episode, number 11, and we're going to be addressing flat roofs on this one, Steve. You know, and as I was thinking about flat roofs, you know, early in my career, I only thought of or maybe saw flat roofs if you're in Arizona or desert communities, or maybe you go to LA. But I can tell you, over the last 10, 15, 20 years, flat roofs have exploded all over the country. Yeah. And part of that is because people like this modern architecture, flat roofs, you know, a big white box kind of thing. I can tell you, I built a bunch of them down here in Texas. I see them in Boston. I see them all over the place.
We've done them in a lot of places.
So this is not just a video or an episode for my, New Mexico, Arizona friends, or maybe LA. This really, if it's not in your area yet, it's coming to your area.
And you know what's interesting is very much like foundations, where I said, you know, we do a lot of hybrids where this section of house is on piers, this one might be in basement, and this one might be in a crawl space. We actually have like 3 projects on the boards where 70% of the house is a pitched roof, and then we have a bunch of flat roof accents in different places.
That's common these days too.
Changing it up a little.
Yeah, the architectural world has definitely moved.
That hybrid, so. But flat roofs. You know, when it comes to flat roofs, the very first thing that I want to talk about is, you know, the venting versus not venting a flat roof. Now, I know I've seen people do it. I've seen failed roofs that don't vent. I'm not here to tell you that you can't build a vented roof. What I'm here to tell you is I would never detail a flat roof as a vented roof. Mm-hmm. I don't think I could be nearly as successful as either one of these details in doing that. So I would never do it. So I have vented a 1 in 12, but flat roofs, unvented is the way I think about them.
Yep.
So that being said, with vented roofs or unvented flat roofs, you have 2 options. I can put the insulation in a cavity, or I can put the insulation outside of my roof sheathing or in the cavity inside the roof sheathing. Mm-hmm. And those are the 2 we're going to talk about. We're going to either over-insulate the sheathing and put all that insulation on the outside. We're going to do kind of a flat roof monopoly.
Yep.
Roof anyway. Or we would just do a flat roof unvented.
As a side note, Steve, I think it's important for us to note, Steve didn't go into the structure of that flat roof. Right. It's because you can do it a billion different ways. Yes. I've seen it with trusses, with hand cut, with eye joists, with, I mean, literally just about any way you can think of, flat roofs are being done out there.
I'm just going to write it in. You can call it a rafter, but in this case, it's very synonymous with a floor joist.
Yeah, that's right.
Right? It's just carrying that upper roof deck.
Yep.
Right?
And if it is a floor joist too, I also think it's interesting to note here, you're showing tapered insulation on the top,
Yes.
which is getting that pitch. You know, a flat roof is, if you've not been on one before, for our younger audience out there, it's not truly flat. Right. It's typically going to want at least a 1/4 inch of fall per 1 foot of direction. So there is, if you were on that roof, there is a little bit of pitch to it, not much. It takes a while for that water to get off that roof, and there's some additional things that the roofer needs to be cautious about because that water takes so long compared to a pitched roof that just swishes right off. But it's not truly a flat roof. However, if you're building a joist system, that usually is flat, and then there's tapering. If this was a trussed roof, if this was a, gosh, there's a bunch of different ways to do it. Often you can pitch those trusses with that 1/4 inch.
You can do it as an eye joist and just put a slight
That's right.
pitch on it, right? That's a 1/4 inch and 12 or whatever.
So there's a lot of ways to do that.
You know, one of the things I learned, we just did one of these roofs recently, the roof sheathing here, we use zip a lot there. Zip on a roof, it's a no-go. It's not warranted to be in a flat situation.
I'm not sure I knew that.
So, you know, we always use, and a lot of people here, they try and use a 1/2 inch. I don't think I would ever do that either. We use 5/8 plywood when we do it. You know, you can go to 3/4 for the reasons we talked about, roof sheathing and such. You can go up to 1.1/8 if you really want to spend some money and get some nice solid roof. But I think the starting point is 5/8 inch plywood.
Makes sense.
There. And, you know, this one here, like you said, this is showing a cut roof, which is pretty easy because if this is a 2x12, I can just simply cut that for the fascia. If this is an eye joist, then this becomes a little different detail structurally in there. And then in this one, like all of our friends where we insulate on the top side, we end up with a distance here that we have to take care of.
Yeah.
Right. So, ready for some challenges?
Let's go. There's quite a few challenges to talk about here.
Water, for one, and you touched on it, right? No roof, even though we say it's a flat roof, it isn't flat.
Yeah, it's not truly
All roofs
flat.
are sloped. And if you look in the manufacturer's warranty on the, say, the roofing membrane, you'll find in there the requirements for the slope for that warranty to be had in there. So the easiest way that I found is you have companies like Atlas that just make a tapered insulation.
Yep.
Right. And you could start them out here as a 1/2 inch. I personally like to start out at 1.5 inches, put a solid end dam there. Then I have stuff I can nail to.
Oh, that's smart.
Because I have a metal, you know, coping and all this stuff. So then I start with my rigid insulation here at 1.5 inches. And then taper up from there.
Smart.
So I just build that into the soffit. As far as air barrier goes, right, this is conditioned. This is unconditioned there. So most of the time I would choose that as our location for our air barrier. Vapor control, again, we're gonna have to do some type of ventilation system in here. Because we don't have a whole lot of insulation there. So we really have this surface there that could potentially be our first condensing surface. And we'll talk about how we can move that, but there's some challenges there. And like always, we have a certain depth there that we have to deal with. Now, the cool thing about the polyiso on the top and starting at 1.5 inches, by the time I get to here, I'm pretty close to 2 inches. So I'm somewhere in like an R15-ish range right at the start of the roof.
That's
so as
nice.
that goes up, it's working in my benefit to use that tapered insulation
That's right.
there. So in this roof system here, pretty much everything that we talked about applies. Again, doing a hard surface there, a couple 2x4s and maybe a piece of 5/4, depending on whatever that dimension. But, you know, by the time I get into here, I'm getting up and I'm, what, R15, probably somewhere around R20 in insulation there. So having this dimension here isn't necessarily as bothersome in the other one because I already have a bunch of insulation on the outside. Vapor, air barrier, all of those things apply. You know, we could use some of that insulation, or we could just simply tape that CDX plywood up there.
That's
but,
right.
Let's look at how we might choose to solve some of this. So this detail here, this is straight out of, if you haven't watched it, go watch it, Build, Show, Build Boston. This is, I literally took the detail out of the drawing set there. And there we did use an I-joist, so you can see how we solved that problem there. The soffit actually came out down here. And we just made that a little bit, you know, different aesthetic solution out there. But as far as the performance goes, obviously that's sloped, water comes out, we have a little kicker there, and we drop the rain. In our case, at Build, Show, Build Boston, we did put a gutter system out there. So we solve for water pretty easily. The one thing about flat roofs, you want to make sure if you're doing a homeowner's manual, or if you're the one taking care of the home, you want to make sure somebody walks that roof once or twice a year.
That's a great point.
And you want to make sure there's nothing up there, somebody, birds or something, didn't core a hole through it that you don't know about, or you just want to make sure that, you know, a stick didn't fall out of a tree and puncture it, as well as if you go up there and you see some ponding, you want to bring that to somebody's attention, because we really don't want these large ponds of water sitting above our conditioned space. As far as air barrier, this one was pretty easily solved for. We simply added some closed cell spray foam. And in our case, we did upwards of about 4 to 5 inches.
Oh, wow.
So we moved that condensing surface that we were worried about here down to here, and we put it in, you know, elevated that temperature. So we basically took it out of the concerned risk arena and put it in. And then basically, as far as insulation goes, we filled the rest of this dimension with cellulose. And you know, this is no different than some of the walls that we've done, where we've done a little splash of closed cell and then filled the rest with cellulose. It's basically the same reason, and this gets back to the whole, you know, 90-degree rotation thing that we talked about with Joe, where if you take a wall and rotate it,
it's the same
the
thing.
physics are pretty much the same thing. We have the luxury of a little bit more distance there. 5/8, some blocking there. Doesn't have to be a vented soffit. So there's a lot of things that are pretty simple about a flat roof. You know, one of the things that always comes to mind is when you're talking to some people are like, oh, I won't want a flat roof. Flat roofs leak. Have you ever driven around America? Like, we literally have Home Depots, Walmarts, Targets. We have millions of square feet
Of flat roofs
out there, right? So the fact that they don't work, I don't know, kind of a little bit of a myth buster.
Yeah, I think that's right.
There. So like our friends of sloped roofs, even though this is a flat ceiling joist, it still needs to be held down.
That's right.
For uplift reasons. So for that reason, it's there. I'm using the closed cell foam in this regard as our air barrier. So bringing up the wall, we can simply put a couple beads of sealant there, seal to it, transfer the air barrier through the plate into that closed cell foam. Pretty simple solution.
Yeah, that's awesome.
You know, this comes from another project that we're currently working on, and this client has an aversion to using spray foam. So that's what's driving it.
Okay.
Right, so we put a bunch of rigid insulation up on top. And again, all that does is, you know, one, you have to buy it, but two, you end up with this distance that you have to solve for. And we've actually had some success with some details. We'll put in a little shadow board here, so you get that little shadow line across the fascia. Depending on how big you make that metal coping, sometimes we'll bring it down and make it a little taller if you did it out of copper or something like that. So
add some interest in detail.
you can add some interest in that detail for sure.
I like that.
But very much like the other flat roof, right? This is sloping down. These two can be straight, but that top layer is the one that's tapered. So if you really think about it, we've just taken this other roof here, and we've taken this and moved it up, and then inserted 4 inches of polyiso.
That's good.
And what that does now, that eliminated the need to come in here because we don't need to elevate that temperature of the first condensing surface.
It's warm.
Here, this is already warm by virtue of having, you know, the R24 or whatever plus above there. Now, in terms of air barrier, if we're using the outside zip, then we can bring that up, we can seal it to that framing member, and then seal these framing members and use our roof deck as our air barrier there. Tape the joints of it, call it a day, and we're good. Or if you wanted, you could do just a minimal splash here and use it as an air barrier. And this would only need to be, you know, maybe an inch there. And then we could fill the remaining with cellulose or whatever it is that we're going to fill it there. But it's a pretty simple system.
Yeah, I'd say so.
And, you know, neither one of them, again, is vented. As far as insulation, you know, it's a function of how deep is that floor joist, right? We fill it up. The project that we're doing, this is actually 16 inches. So we're going to end up with a pretty healthy roof. Yeah. So right there, we're at our 64 plus our 24. We're going to be right in our 88, our 86 roof for that house. That's flat roofs in a nutshell. You know, they're not, a lot of people would sit there and say, oh, flat roofs, I don't want to do them. They're so complicated. From a building science perspective, they're pretty straightforward.
Yeah.
It's a question of, am I insulating in this cavity, and where is that condensing surface?
If I could point out one thing that that I've struggled with over the years is when you move to do this overhang, there is some structural gymnastics that need to happen. And a lot of times where I am in Texas, we'll use roof trusses. It's just basically a floor truss except on the roof. And those trusses run from inside to out, which means that this solid block you're showing here is a hard one to put in because we just got a lot of airspace. So be cautious with air sealing. You know, for instance, on a job that I've got going now, we're going to use some open cell foam, but we're also going to do some aero barrier. I really want to make sure that this is a really airtight connection out here from the inside to the outside. And structurally, it can be hard to add those overhangs. The other thing I do want to mention, we don't need to get into this necessarily today in too much depth, but a flat roof doesn't provide as much protection for the walls as a pitched roof does. And on days where there's a little bit of wind and some rain, you'd be surprised, you can actually get water landing almost to the top of the soffit. That roof pitch acts like an airfoil, like the whale's tail in the back of your Porsche or your you know, your sports car that's pushing down. The same happens with the wind when it hits a house with a pitched roof, and so the walls get wet much lower than a house that has a flat roof with an overhang. So that's something to keep in mind when you're thinking about flat roofs. Certainly they can be done. Steve and I have built a lot of different assemblies, but in general, flat roofs have a little bit less forgiveness than a pitched roof, and so you just need to keep that risk profile in mind.
You know, it's interesting, Matt. I didn't draw it here. I said this is the Build Boston detail. So we did this. We did I-joist. So this would answer your question about trusses. So we had the I-joist, and it ran all the way out.
There you go.
Right. What we did was we put blocking in here. We sprayed the closed cell here, and we also had our insulator
spray the outside. There. Smart.
And that way there we've captured it from both sides.
Yeah.
From an air barrier perspective.
It's a belt and suspenders right there. Yeah. That's really smart,
so
Steve.
That's how we solved that.
Goodness gracious, Steve. We've gone through a lot of stuff, man. 11 episodes on Building Science 301. Big thanks to my friend Steve, by the way. Steve probably spent a solid week plus in terms of his hours putting together these incredible cross sections for y'all. And we had to limit it, right? I mean, Steve probably could have done, what did we do, 30 slides? 33 slides plus 2 per slide. So that was 66 images we went through in the series. We probably could have done 266.
Yeah,
but
very easy.
Steve's already outlined, with the help of our friend Mark, a 401, a 501, a 601. We have a lot more that's in the hopper on this series. And so if you're watching this 301 and you didn't watch 101 or 201 for whatever reason, Steve and I would really encourage you to go back and watch those. And let's say you're the owner of the company, you're a builder, you're an architect. Think about those people that you're mentoring, those people below you, the younger superintendents, the younger architects. Encourage them to go back and watch this series as well, because we really think that everyone should have a good foundation for building science. I've encouraged my trades to go back and watch this. I want my electrician, my plumber, my carpenter to know building science and to say, hey, something's not right here. The TSA has that saying of see something, say something. I think the same needs to be said in our job sites. When we see something that we're concerned about, we should say something. And so with this foundation now, we're up to 301. Yeah. I think we've given you a good basis for understanding building science and how physics is interacting to our buildings. What did I miss on that, Steve?
So,
what do you want to add?
What I would say is, whether you've been in the business 30 minutes or 30 years, this series is for you.
That's right.
Right? 30 minutes, obviously there's a lot to learn here. You're going to be drinking from a fire hose. But for the gents and ladies that have been doing it for 30 years and say, I know what I'm doing, I don't need to do this. Well, there's a couple things. One, you can watch the series to reinforce what you do.
That's right.
And if you walk away saying, yeah, I do it exactly that way, then good for you. We're both on the same page. The second aspect is, if you've been doing it for 30 years, then I challenge you as a leader. It is your responsibility to make sure everybody that works under you, subs included, understand what we're doing. And I don't mind, and I don't think Matt minds, if you use this series as a way, if you steal our teaching technique to teach the industry. This isn't about us sitting up here and giving you a lecture.
No, that's right.
This is up here showing you, this is an example of how we're thinking about projects, maybe how you should be thinking of projects, but more importantly, and I'll steal this one from Joe, no information in the industry is owned by anybody.
That's right.
Right? He always told me, we're curators. That's all we are. We don't own it. There's no ownership to information. And in being a curator, it's our responsibility to take what we know and ensure the younger generations know it. If you sit there and you're one of those guys or gals, the industry, we're losing people, nobody wants to come into this. Well, you know what? As somebody that's been in it 30 years, it's your responsibility as a leader to make sure that we get these younger generations in it. I'm very fortunate. 2 of my 3 kids have taken up architecture, and we actually spend time in the office on Mondays and Friday mornings, and we'll go over a small topic like this. We'll talk about an unvented roof. We'll talk about how do we deal with moisture in a basement or water in a basement. And we'll have those talks because it's our responsibility.
Huge. So good, guys. Thank you so much, Steve. What a great series. Steve, with that all being said, I want to say a big thanks to our friend Joe Stiebrick that we've learned so much from. As Joe always says, it's not rocket science.
It's build science.
Build Science 301, a Build Original series brought to you by Anderson Windows and Doors, Arklin, and Huber Engineered Woods.